This video is for Lesson 3-2 about conditional statements. Learning goals are to identify the hypothesis and the conclusion of a conditional statement and to give counterexamples to show that some conditional statements are false. Rules of logical reasoning involve using a set of given statements along with a valid argument to reach a conclusion. Statements that are to be proved are often written in if-then form, meaning that these sentences begin with the word if, and then in the middle of the sentence there's the word then. An if-then statement is called a conditional statement. In these statements, the part of the sentence that has the word if is called the hypothesis, and the part of the sentence that has the word then is called the conclusion. In ELA class, you've studied different kinds of sentences. There are interrogative sentences, which are questions. There are declarative sentences, which state a fact. And there are conditional sentences, which have the words if and then. These are the kind that we use most often in geometry. Take a look here at example A. Here is a conditional statement. It begins with the word if, and later on is the word then. If 3 times x plus 2 minus 1 is equal to 5x plus 11, then x equals negative 3. The beginning part of the sentence, the part associated with the word if and before the word then, is called the hypothesis, and that's this portion here. The second part of the sentence, the part associated with the word then, is called the conclusion of the sentence, the x equals negative 3. Here are some try these questions. Here we have a conditional statement. If x plus 7 is equal to 10, then x equals 3. Answer these, try these questions. I'll pause the video. And here are the answers. Question A, what is the hypothesis? So the part of the sentence with the word if is x plus 7 is equal to 10. Question B, what is the conclusion? That's the part of the sentence with the word then, and that's x equals 3. What we're saying is, if we have x plus 7 equals 10, then we can conclude that the value of x is equal to 3. And that's called solving that equation. Question C, state the property of equality that justifies that conclusion. To go from x plus 7 equals 10 to the conclusion that x is equal to 3, we would have to subtract 7 from both sides to solve the equation. That's the subtraction property of equality. Conditional statements may not always be written in if-then form, but they're still conditional statements when you think about the true meaning of the sentence. And in those cases, we could rewrite the sentences so that they do have the word if and the word then. For example, question 1, let's restate each conditional statement using the words if and then. Question A, I'll go if you go. If we were to rewrite that so that it has the words if and then, it would look like this. If you go, comma, then I'll go. It has the same meaning as that original sentence, but it now has the words if and then. Question B, there is smoke only if there is fire. Let's rewrite that one so it starts with the word if. If there is smoke, then there is fire. Question C, x equals 4 implies that x squared is equal to 16. So it would look like this. If x equals 4, then we can conclude that x squared equals 16. And now the sentence has the words if and the word then. An if-then sentence is false if an example can be found for which the hypothesis is true and the conclusion is false. Finding an example that does this is called a counterexample. Number 2, here is a false conditional statement. If two numbers are odd, then their sum is odd. Let's identify the hypothesis, and then in question B, identify the conclusion. The hypothesis is 2 numbers are odd. The conclusion is their sum is odd. Question C, give a counterexample for that statement and justify our choice of that example. A counterexample means we want to find an example of two numbers that are odd, but in our example, the sum doesn't turn out to be odd. So here are two odd numbers, 3 and 5. Let's sum them, and notice that the sum is 8, an even number. So this example shows that that original sentence was a false sentence. An example that shows that something is false is called a counterexample. Here are some check your understanding questions. I'll pause the video for you to solve these. Here are answers to the check your understanding. Number 3, if you can find an example for which both the hypothesis and conclusion of a statement are true, is the conditional statement necessarily true? The answer is no. Just because you can find examples where the thing works doesn't mean there still might not be counterexamples that show the statement doesn't work. Number 4, give an example of a true statement that includes this hypothesis. An angle is named angle ABC. So I want that phrase to start my sentence. Here's a possible answer. If an angle is named angle ABC, comma, then its vertex is B. This is a true sentence. Number 5, give an example of a true statement that includes the conclusion, the angles share a vertex. So here's one possible sentence in number 5. If angles are adjacent, then the angles share a vertex. So notice that I have that phrase in the conclusion part of the statement. Number 6, Caesar conjectures that the quotient, that means division, of any two even numbers greater than 0 is odd. Question A, write his conjecture as a conditional statement. So I want to have the words if and then in there. How about like this? If two even numbers are greater than 0, then their quotient is odd. I want this sentence to have the exact meaning as this original one that I was given. The only difference is it has to have the words if and then. But I don't want to change the meaning or the order of the sentence in any way. So I think how I wrote it for 6A is okay. Now question B, give a counterexample to show that that statement is false. So this sentence begins with having two even numbers that are greater than 0. Can we think of two even numbers greater than 0, and then if we find their quotient, it doesn't turn out to be odd? How about the numbers 16 and 2? Those are both even, they're both greater than 0. If we divide them, it makes 8, which is not an odd number, and so this would show that Caesar is wrong. Number 7, write the definition of collinear points as a conditional statement. I've got that up at the top of the screen. If points are collinear, then they lie on the same line. In this lesson, we discussed the hypothesis and conclusion of conditional statements. Conditional statements can be written using the words if and then, and the hypothesis is the first part of those sentences, and the conclusion is the second part of those sentences. And we discussed how if you can find a counterexample, then that shows that the conditional statement is a false statement.